so maybe let's just get started. Hi, folks. Welcome to another episode of YFTT. Once again, we're going to be talking about query optimizers. The framework or this paper that Dmitry is going to be presenting that his work is based off of is called TAQO for short, right? So just like the food, but anyway, it's query optimizers, not food. If you have any questions, post it on the LinkedIn comment box. Please join our community Slack. If you have any questions as well, you can ask it in the YFTT channel. Let's get started. So Dmitry, maybe just quickly introduce yourself, and we can jump right in.
Hello everyone. My name is Dmitry. As far as I understand, this is probably the first Friday Tech Talks from QA team. So we will show you something about how we test our product today, and this.
Awesome.
Yeah, should I start?
Yeah, let's start. So maybe so TAQO expands to, I guess, that, right? Testing accuracy of query.
Yes.
Okay, got it. It's a clever acronym. Let's go.
Let's start with the how usually everyone tests query optimizer and execution. So there is few approach they widely used. So the first layer is unit and integration tests. So it's really simple test. Basically, it just contains we have a query and we evaluate the explain based on this query, and we expect to see, for example, index scan for that. So this is great. So we can test our optimizer at the stage of development. We can say that it works as expected. The problem here is can we really say that this scan will be effective for the distributed system or not? So we can't test this on the unit or integration test level. The next one is also widely used, so benchmarks and micro benchmarks. There is a lot of benchmarks there, so TPC, join order benchmark, click bench, a lot more benchmarks. They're great, so they cover a lot of cases, but still it's not exhaustive testing, and we still might find issues in query. We might have a very simple query that can give us very unoptimal execution plan. This still could happen. Couldn't cover everything. And the final, there is SQLsmith, originally Postgres compatible tool, and SQL Answer. We have an implementation for both. So the problem is random query generation, and this is for SQLsmith mostly. So we generate this query, and we got the result, and we can't really say is this result effective, right? So especially for SQLsmith, we just generate the query, we get the result, but this result is valid or not, we can't say that. SQL Answer is trying to fix that by tuning the original query, but still it's not about query optimization performance. So we evaluated query, there is no timing for that. So just say, is it compiled or not? Is the result is expected?
So that's more query correctness.
So there is definitely
performance, right? That's how you. Okay.
Yeah. Yes. So let's search for alternative methods. So what we want to see from our framework is so adding new cases should be as simple as possible. Ideally, we should do nothing for it. So we don't need to create Java, Python, C++ code. So our API is SQL, and we want to use this SQL for test integration. It's the most simple way to create a new test. And this will allow us to cover to use popular benchmarks. We just can copy queries, and that's all. We already support that. We should mostly have the clear failure criteria. So there is a problem with that, obviously. So there couldn't be the clear failure criteria for query optimizer, right? So there is a lot of problems that might be here and there, but we will try to solve that. And reporting should be readable. So in case of benchmarks, our reporting is just numbers. Instead of unit integration test, is just true or false. So it's not many information could be getting there. And we should spend more time on querying the same cases manually and get all information that we need. So while searching the papers about the testing query optimization, there is very interesting one, I think, called testing accuracy of query optimizer. And I will briefly show you what this paper about. So yeah, as it's named, they test query optimizer accuracy. So what does it mean? We evaluate the original query, we collect the estimated costs and actual execution time. We evaluate possible optimizations, and we create this plot of cost estimate versus execution time. So for ideal optimizer, this line should be linear, but obviously it's not possible. I don't know database that that have linear distribution. So we can't really use the exact algorithm from this page, but this is very interesting idea. So if we have the query and we found the better execution plan, then most likely we should look at this query, right? So this is the good start from our finding the failure criteria for our tests. And let's automate this. So what we need to use PG hint. We have a Friday Tech Talk about PG hinting, and we have a few blogs about using it on Dev2. So what we need to do, we need to define this almost a comment part, introduce the almost a comment part in our query and define at least 3 things. So there should be leading, that will define our join order. We should define join types that will be used to join these tables, and we should define the types of scan that will be used against the table.
So one question, Dmitry, from Venkata is, do you benchmark on historical queries encountered in production, or what are the set of queries that you benchmark on?
We can use, as I said, we can use the knowing benchmarks, but we also add a lot of queries from our example. So we have the exhaustive part of the testing, the test cases is queries that we made from scratch. I will probably explain a bit later, what we what we wanted to achieve is that if we use the if you always will test your system using TPC-H benchmark, you will be effective only in this benchmark. So you will
you need the variety. You need a variety.
Yes,
so,
yes.
Yeah, you do a lot of on-the-fly query generation also, right?
Not right now, but we have plans. Yeah.
Got it. Okay. Yeah. Hopefully that answers your question, Venkata. So not just in production, not just with the test bed, but more than that.
Yeah. So and what we basically need to do, what we just need to extract table names from the original query, and this is it. So all we need is just table names, and we were able to generate PG hints. So let's automate this and how it will work. So here's example. If we have, for example, three tables in our query A, B, and C. For the leading hint, we just can generate all possible permutation, and this will stay to our optimizer in which order tables will be joined. And based on this, so for each element in this list of the permutation is our leading hint actually. So we can use this to generate a leading hint. And after we generate the leading hint, we have the join order. We are able to generate the join hints. So this is pretty simple algorithm. And after that, after we have leading and join hints, we need to generate scan or index scan hints. And so we have just a flag. So if table have index, we need to check index scan for this table. This works great for 3 tables, but the problem started if we have 4 tables in the query. And what we use to reduce number of possible optimizations, we use pairwise technique. So this is the commonly used technique in the testing. So, and the idea is, it's a method finding defects by using combination of 2 factors, and the most defects can be found by using combination of 2 different factors. And the example of usage that in this case, so we have, for example, 4 tables in our query. We have 3 joins that should be used to join these tables, and each join can be nested hash or merge join. So instead of 27 possible combinations using pairwise, we got only 9. And you can see, I highlighted here so each combination of join between 3 tables is covered. So we have nested, nested merge, nested hash, and so on. So each combination of 2 joins is here, but you will not find here the merge combination, for example. So we will just throw it away. It works great for the most of the cases. So yeah, we don't want to evaluate thousands of possible combinations, and this gives us like reasonable set of possible combinations. Another way how you can reduce the possible optimizations, you can say directly, I don't want to use, for example, like nested loop join for this query, and you can say that in comment area. So SQL file has comments. You can use these comments to say like, I don't want to use nested loop join. And the final one, we don't want to spend hours on evaluating all possible optimization, and we just limit the execution time by the currently the best execution time. So if we got our default query evaluates in 20 seconds, we found the query that evaluates for 5 seconds, we will limit our query timeout with these 5 seconds. We don't need to spend time on that. So more details about framing. So I'll describe the main algorithm, how it works. Input data, as I said, is just SQL file. All the features that SQL file provides, actually, like we use them, and that's all we need. And this like simplifies adding new cases, like so we can just create like few files and testing suite is here. And every person actually can do that. So each query evaluated few times, and we collect in average execution time. We need more precise data here. We don't hard coded our system under test. So it could be any cluster, it could be local cluster, it could be like multi-zone cluster, it could be the multi-cloud cluster. Doesn't matter. We can evaluate this test against anything. Obviously, TAQO algorithm execution time depends on testing queries that we have in our suite. So on the right image, you can see that there is pretty complex queries with right outer joins distinct order by offset. So this suite might take like hours to evaluate because of a lot amount of combinations that we need to test. And about reporting, we use HTML and XLS formats because everyone can open them, everyone can analyze them. So we don't have very special reporting here.
And this is all open source, right, Dmitry?
Yes, it's open source. It's currently in my personal.
Okay, we'll move that to the Yugabyte repo, but yes.
Instead of demo. So demo would like is very boring. So we have few steps. We have the drop. We have like DDL steps: drop, create, import, and analyze. And they're optional, so you can disable, like if you have already system with data, you can just disable these steps and you can just evaluate the queries that you want. So yeah, demo in this case would be like watching how progress bar is completed. Not very interesting. But on this stage, we can actually detect, we use this in regression testing. So if we corrupt something in optimizer and like for some queries, they started, some optimizations could be corrupted, and we can detect this on this stage. So console output will contain a few exceptions about like query cannot be compiled with these flags. Very helpful. About reporting. So what does reporting contains? So we have a query, obviously. We have this TAQO plot. This is the a few words about this query. So this case is already fixed. It's like it was one of the first reports that we used. So on this plot we have, so in this example we have a query that evaluates almost for 2 seconds, but we found the better optimizer plan that could be evaluated 10 times faster. The numbers here on the plot and in explain analyze are not exactly the same because we use so there is different steps. So we use explain analyze to collect execution plans only, but the other step is to collect like we evaluating query and collecting the results. So there is the timing on the plot is actually like query execution plus a result collecting step. So that's why time is different. But on this example, you can see that we have, so instead of sequential scan, we should use index scan. And yeah, it will improve our execution time. What else we do collect? So as you know, we are Postgres compatible, so why not to evaluate same query against Postgres? And you can see that in Postgres, we also see index scan. And this means that, so it's actually, yeah, it's a fixed problem. And you probably can understand why, like, what is the problem by the number of rows is different. So we have.
So to reframe this, right, Dmitry, I think what you're saying here is because the Yugabyte's like general execution framework code and cost-based optimizer, all of this is the same as Postgres. I think the gaps can be like, we may be collecting, the costs estimation may be a little off because
Yes.
the underlying storage is different, right? So what you're saying is this framework can help bridge that gap by making it very easy to compare how would Postgres have done it versus how does Yugabyte do it, and kind of cover the gap quickly, right?
Yes. And yeah, you can also notice that there is like PGBest and PGBest. So Postgres optimizer also, so we found few queries where Postgres optimizer is not the best. So yeah, we also validate Postgres for the same, we're using same criteria. And yeah, additionally, we validate, we have another validation. So cardinality, we validate cardinality for the queries that does not contain order by. For the queries with order by, we actually can validate is the result the same with the Postgres. So it's another layer of another fail criteria. And for more complex case, so you notice that we use Git-like difference between execution plan, and for more complex cases, is actually like it not cover everything. Like obviously some sophisticated tree comparison will be the best, but the Git works perfectly for the like almost the same execution plan. You can you can see where is the problem. So we have a problem with nested loop join here. And let's see more information about this query. So you see that we have the same TAQO plot, but there is much more optimizations that we evaluate. So what this gives us, so a lot of statistics about like how optimizer works. And you can see that we also have like the red square here, the default execution plan, and the green dot surrounded by other dots. So we have actually a set of the best execution plans, and using that we can build the statistics around that and say like which nodes in our default execution plan probably faulty. So on the image in the right, you can see that we highlighted nested loop join and index scan here, which is also a known issue. But like this is another like semi-automated check that we can provide. It's very simple right now, but yeah, it's just a start. It just was yeah, very simple to implement that, and it's very effective in some cases. I also told about the Excel reporting. So we have few types of reports. This is the comparison with Postgres report. There is like some color codes here. So like if our default execution plan is the best, we highlight the UP best as green one. If we found the better one, we just don't highlight that. If we are okay with our ratio against Yugabyte, Yugabyte versus Postgres, we highlight it as a green. If we don't okay with that, we highlight it as red or yellow. Yellow means that execution plans are the same, but like the difference is huge. We should fix that. And finally, this is probably the most powerful one. It's very simple. So we don't use the TAQO algorithm anymore. We use it in regression testing and testing new features. So this is the repo for the budget nested loop join. This is some of the developer build. So it's not, so yeah, it was fixed already, but this shows the power, how it can detect the issues in developer builds. So
so one question, Dmitry, from Venkata is, won't the execution time depend on the database configuration, or do you assume the default configuration?
Yeah, as I said, so yes, obviously it depends on database configuration. And the idea of this framework was exactly to remove these dependencies. So we can evaluate this framework against any database. You can configure, you can define. If you want to simple local run, you can say directly. So framework is able to compile the Yugabyte code and start Yugabyte code in your local machine with flags and master flags. Yeah. But it also can be, and it gives us the power of comparing database. So if we want to compare how 3-node database performs against 5-node database, we're able to do that.
Yeah, so, but I think the key point, I think, Venkata, is that you can actually configure the database a different way. But one of the core principles of, I mean, at least one of the things that we're trying to go to increasingly is to build in adaptive defaults into the database. So you don't really have to special tune it for certain scenarios. So that's on one side. And then on the other side, if you are going to very specific deployments like multi-region deployments, et cetera, you can, I guess, use the TAQO framework to figure that out. But this is more around the internals of the database to see how it is planning to do stuff in scenarios more so than what happens in certain specifically deployed scenarios, right?
Yeah. So so on this slide, this is the example of, so there's few things here. So this is the regression report. So we compared two versions, some master and budget nested loop join build with 1000 value as a G flag. This is also a new feature testing example. And it's so during the analyzing this report, so you can see here that we have a queries that performs 20 times faster, 2 times faster. We even have examples 100 times faster. I think this is the best improvement by using that budget nested loop join. But also you can see here that there is a query that started to perform worse. And we can detect this query. So we have hundreds of these queries, and just looking at this report, you can see where is the problem, and you can open the HTML report and get exhaustive information about what went wrong, what's the difference in execution plans, and so on. So in regression, it's super powerful, and yeah, we are using it in testing every feature. Yeah, what goals did we achieve by using this framework? So yeah, as I said, we using just SQL files, so we can just we just need to tune some framework, some if we have based on that. We have the query criteria. It's not simple, so we have this TAQO validation. We have a comparison with Postgres. We have we even have, so there is a lot of improvements that can be made. We can validate the execution plan internals if the values there are expected. So yeah, we just need to use regexp, I guess, for that. We are not hard-coded to environment, so yeah, we can evaluate the suit against anything. We can then compare how we perform, how 3-node environment performs against multi-cloud environment. We can validate that. And report is constantly tuning. So based on feedback from developers, I'm constantly tuning the report to provide as more information that needed to analyze the initial problem. And yeah, we use it on regression stage as a QA, and it basically used by on all stages. So it's used on development side, developer development, on research and QA, so everyone can use that. About the roadmap, so obviously we want to extend coverage. So there is a lot of cases that we don't cover yet. We have only few known benchmarks right now, but yeah, there is a plan to add them. We don't cover DMail queries, but yeah, it's we will add them. Probably adding random query generation. So probably some simplified version of SQL Smith. So I mentioned that this is like self-testing system, so we don't need so we can use Postgres as a side testing, but the system itself can be like tested. We just need the query, and we already can generate all possible optimizations, and based on these optimizations said that we maybe have a problem, so we can use random query generation here. Adding more sophisticated automated checks, as I said, we have only a few of them. There is a lot of ideas how we can improve this. And yeah, collecting more data about query execution process, probably collect flame graphs and so on. So we can also add this to our report.
Awesome.
Yeah,
this is fantastic. Let me see there. I don't see there are any more questions. So one thing I remember, if I from some of the things internally, like since there are no questions and there's like a couple of minutes left, you are able to because YugabyteDB is Postgres compatible. One of the interesting pieces of work that we're undertaking is to also look at what the performance would be in distributed scenarios for the various Postgres execution nodes, right? So using this framework, you can also look at basically driving queries through the different execution nodes in order to see what the, for example, Joe asked about batch nested loop joins, right? And we are getting that out, Joe, absolutely. But the case in point is, suppose we're looking at nested loop joins and what its impact is on a distributed database, like when you try to do that, and do you need to optimize that? This kind of a framework can be used to actually do a more large scale analysis of the different Postgres execution nodes. Isn't that right?
Yes. So yeah, that is like the simplicity of this framework. So we're able to do anything. We can generate reports that we need. We even have reports for different features. So yeah, it's very
and I think one of the most exciting things,
resilient.
Yeah. And one of the most exciting things for me about this is that, on one side, we have Postgres, which is the code base we're using. And on the other side, we have this framework. And between those two, we're able to drive YugabyteDB closer and closer to Postgres-like planning and performance and predictability. And so that's actually pretty exciting from the point of view of a lot of the users. So that's really exciting. And yeah, and thank you for all this effort, Dmitry, You built all of this framework in which framework or language did you use to build it?
Oh, I used Python since it was picked because there's potentially a lot of statistics that we can collect from the execution, and Python is the best choice for that. So yeah, that was the idea basically. That we have access to some data science stuff in Python. Might be interesting to use that.
Fantastic, awesome. So looks like no more questions. Thank you, folks, for joining. And once again, we'll be here, Dmitry will continue to answer questions. So please feel free to post questions. Continue to post it on the LinkedIn comment box, or you can join our community Slack, YFT, yugabyte.com/Slack. Go to the YFTT channel. We'll be looking at that as well. And join us next week, same place, same time, for another YFTT, which will be about yet another interesting topic. All right. Thank you, folks. Thank you, Dmitry. Really appreciate all of the information. It's really, really exciting. Thank you.
Thank you. Yeah.